Okay, here is, what is this, exam number 4. Not exam number 4, but exam problem number 4. And in that, we were given a couple of uniform distributions. So F1 of X1 was 0.2 or 1/5, and that was on 0 to 5. And F2 of X2 was 0.1 on 0 to 10. And we were asked to look at the sum of those two variables, so y equal x1 plus x2. And you know, everybody used our theorem, and so just wanted to make sure, you know, looking at bounds. Depending on what you integrate with, you know, for, then you'll get different bounds. But so we'll start with x1 plus x2 is going to need to be less than or equal to y. And so if we integrate with respect to x1, then we need x2 in terms of x1. So x2 is less than or equal to y minus x1. And now what we know is that we also need 0 less than or equal to x1 less than or equal to 5, and 0 less than or equal to x2 less than or equal to 10. So now I take the x2 and plug it in here, and that changes this to 0 is less than or equal to y minus x1 less than or equal to 10. And if I work with that, I can subtract y from both sides, so minus y less than or equal to minus x1 less than or equal to 10 minus y. And so if I make that a positive x1, inequalities change directions, and so multiplying through by a negative 1, I get, y minus 10 is less than or equal to x1 is less than or equal to y. So for x1, we have those two items. 0 is less than or equal to x1 less than or equal to 5, and y minus 10 is less than or equal to x1 less than or equal to y. And then, of course, y, because it's the sum of x1 and x2, it's going to be no smaller than 0 and no bigger than 15. So putting those all together, you know, what the heck does that mean? Well, so x1 needs to be greater than or equal to 0. And so if y is 0, and we look at, say, this other inequality here, if y is 0, we've got no problem on the the left-hand side of this inequality here with x1, because we've got negative 10. Well, the inequality up here says 0, so that's not a problem. But if y is 0, x1 will have to be 0 because of the second inequality. And so what's going to happen is that we'll have one set of inequalities, 0 less than x1 less than or equal to y, and that is going to be when y is between 0 and 5. Okay, because once y gets up to 5 in this second inequality, then x1 can get no larger. Okay, so we have that. That's going to be one of our cases. Now, what about if y? Now, I'm going to use, I'm going to be sort of sloppy here and use a less than or equal to there. Probably I should use a strict inequality on one of the two of these, but so now we ask what happens when y gets bigger than 5, and up here in the second, so again, this one, in the second inequality, if y is 5, then we still, on the lower bound in that second inequality, we still just have -5. Well, x has got to be bigger than 0 anyway, and so we'll have 0 less than or equal to x1. And then let's see, so if y is at least 5, though, x1 can't be any bigger than that, and so that will be less than or equal to 5. But when does that stop? Well, when y hits 10, the second inequality becomes a 0 on the left-hand side, and so things will start changing at that point. So we'll make that 10. And then finally, when y is 10, at least 10, and then up to 15, what we see is that in the second inequality here again, that we're going to be bounding below by y minus 10, because that will be greater than or equal to 0. But the y starting at 10, that's no problem, and so x1 will be less than or equal to 5. And so that's what we're going to get for our PDF using our theorem. Is we're going to have 3 cases, and so we'll have the case for y less than or equal to 0 less than or equal to 5, 5 less than or equal to y less than or equal to, well, now at this point though, I'm not going to be so sloppy. Let's make one of those a strict inequality. 10, and then 10 less than y less than or equal to 15. Okay, so we have that, and we'll have to do our integrals here. 0 to y is the first one, so 0 to y of 0.2 times 0.1, so 0.02 dx1. Now, you need to evaluate that to get 0.02y. Then the integral from 0 to 5 of 0.02 dx1, and that is equal to 0.1. And then what was the last one? Y minus 10 to 5. So integral y minus 10 to 5 of 0.02 dx1. Well, that one I didn't really leave quite enough room, because I'll get a 0.1 and then minus 0.02 times y minus 10. And so 0.02 times 10 is 0.2, so that's a 0.3, because I've got a minus and a minus, and then minus 0.02y, and that goes with that one. Okay, so that was if we used x1. Now, so some of you might have used x2, so I thought we'd check that, and so again, we have x1 less than or equal to 5, 0 less than or equal to x2 less than or equal to 10. And again, we use that x1 plus x2 is equal to y. Solve for x1 in this case. X1 equals y minus x2. We'll get some symmetry, but not totally because of the 5 and the 10. And so we have our x2, but I need to substitute for the x1, so I get y minus x2 is less than or equal to 5, and so this becomes y minus 5 is less than or equal to x2 is less than or equal to y. So up here, we had y minus 10. Okay. So then we also have y, of course, is less than or equal to 15, greater than or equal to 0. And so now we need to work on these same things as we did before. So we're just going to kind of go through the same sort of stuff we did back here. You know, we had this, and so this part here, and so what did that imply? And so we're working with the items 0 is less than or equal to x2, less than or equal to 10. Also, y minus 5 is less than or equal to x2, is less than or equal to 10, y. And then 0 less than or equal to y, less than or equal to 15. And so as we look at this, again, if y is 0, so if we have 0 less than or equal to y, we have no problem with this second inequality. That's down at -5, so the x2 would be less than or equal to, or greater than or equal to 0. And then, but on the other side, we've got y, so we have that. And that will, we'll use this inequality up to 5. Now, before, you know, before we kind of had, we went up to whatever x1 had been, which was 5. But what happens here is, yeah, at y equal 5, we could still go up higher on the second inequality because the x2 is less than or equal to 10. But once we hit 5, this part all of a sudden gets to 0 and then starts being a bound on the x2. So we'll still be between 0 and 5. Now this one is going to be between 0 and 10, and in this case we have y minus 5, because if y is 5 or more, this bound starts to matter. And this bound still matters as long as y is less than 10. And so we get x2 less than or equal to y. And then finally, from 10 to 15, well, at 10, 10 to 15, let's see what happens. X2 is still going to be bounded that way, so y minus 5 less than or equal to x2. less than or equal to, but if y is at least 10, well, x2 can never be bigger than 10. So we get those three bounds. And now we integrate with respect to x2. And so we'll have an integral from 0 to y of 0.02 dx2. And that is 0.02y. And that's for y between 0 and 5. So far we're matching our first answer. Then we have integral from y minus 5 to y of 0.02 dx2. Well, that's 0.02y minus 0.02y minus 0.02 times, oops, 0.02, that's not a 0.02. Oops, try that again. 0.02 times 5. But that's 0.1. And that's for 5 less than or equal to y less than or equal to 10. So that agrees with what we had before. And then finally we have our integral from y minus 5 to 10, 0.02 dx2. So we get 10 times 0.02, which is 0.2, and then minus our 0.02y, and minus, and 0.02 times 5 is 0.1. And that is equal to, again, 0.3 minus 0.02y. And that's 10 less than or equal to y less than or equal to 15. So there we go. We got the same answer using both variables. So that's always good. Okay, that's number 4.